one falling apple, one curious mind, one idea that rewrote the universe. In the stillness of 17th-century England, a young scholar named Isaac Newton looked up and saw a world full of hidden patterns. When an apple dropped before him, most saw gravity in action. Newton saw a question: what invisible hand pulls everything down, and could it stretch beyond the earth? Mattermosaic, piecing together the universe, one discovery at a time. The spark of curiosity. It was 1665. The Great Plague ravaged England, forcing universities to close. Newton returned to his family home in Woolsthorpe, isolated yet free to think. He spent 2 years in what he later called his years of wonder, experimenting with prisms, grinding lenses, studying the motion of objects, and above all, pondering how the universe held itself together. Then came that quiet afternoon under the apple tree. An apple fell, ordinary but profound in its simplicity. Why does it always fall straight down, toward the center of the earth? Could that same pull act between the earth and the moon? From apples to the cosmos, Newton began to imagine the impossible. If gravity reaches the apple, perhaps it also reaches the moon. What if the moon is constantly falling, just like the apple, but moving fast enough that it keeps missing the earth? That single thought bridged the gap between heaven and earth. He realized that the same invisible force binding the apple to the ground might also hold the planets in orbit around the sun. It was a unifying idea, the first of its kind in human history. The cosmos was not separate from us. It followed the same rules. The great insight: Newton calculated how gravity weakens with distance, how it grows stronger as masses increase, and how it gives shape to the motion of worlds. In his notes, he compared the pull on the apple with the force keeping the moon in orbit. The numbers aligned. The same law governed both. This was the first glimpse of what he would call universal gravitation, a law so simple, yet so sweeping, that it explained tides, planetary motion, and even the falling of a pebble. It turned the chaos of the heavens into an elegant pattern, one rule to explain them all, writing the law of gravity. Years later, Newton formalized his discovery. Every object attracts every other with a force proportional to their masses and inversely proportional to the square of their distance. F G M equals 2 R2. With that single equation, the universe became knowable. For the first time, motion could be predicted, not just observed. The same math that described a falling apple could also describe the path of comets, moons, and planets. Heaven and earth were united under one cosmic law, the legacy of a falling apple. In 1687, Newton published Philosophia Naturalis Principia Mathematica. The Principia reshaped science, turning speculation into precision. It inspired generations of physicists and astronomers to see the universe as a system of interlocking forces and predictable motions. Centuries later, Einstein would build upon Newton's work, revealing that gravity is not a force pulling through space, but the very curvature of space and time itself. And yet, it all began with a simple question, and a man willing to follow it wherever it led. From that moment beneath an apple tree, Newton revealed a universe connected by a single, invisible thread. Every orbit, every fall, every motion became part of a greater whole, a grand mosaic of cause and effect. His curiosity bridged earth and sky, and changed forever how humanity understood its place in the cosmos. Mattermosaic, piecing together the universe, one discovery at a time.